Hi, my name is David Rangrade. In this video, I am going to solve a staircase problem. In this problem, you are given a staircase with s steps, which means if s equal to 2, you have 2 steps in the staircase. If s is equal to 3, then you are going to have 3 steps in the staircase. And assume that you are only allowed to take either 1 or 2 steps at a time, which means if you decide to climb 1 step from the ground like this, and from there you can see there is only 1 step left, so there is only one possibility from here to jump from step 1 to step 2. This is one way of climbing the staircase. You can directly jump from the ground to step number 2. In case you have only 1 step in the staircase and you decide to take 1 step, then you see that there are no further steps left. Then the number of ways to climb the staircase would be 1. And if you have 0 steps in the staircase, you can try to jump 1 or 2 steps, but you will always come back to the ground. That means number of ways of climbing the staircase would be 1 as well. Let's take a bigger example where s equal to 3. First, you decide to take 1 step from the ground, and from here you have 2 possibilities. Either you can jump to step 2 or step number 3. So you decide to take only 1 step, and from there is only 1 step left, so you can't take 2 steps, so you jump to step number 3. This is one way of climbing the staircase. Another way, from step number 1 you can take 2 steps and directly go to the top of the staircase. This is second way of climbing the staircase. As you have already taken 1 step, you can jump directly to step number 2 from the ground, and from there you have only 1 step left, so you can go to the top of the staircase like this. So you have 3 ways of climbing this staircase. Similarly, for s equal to 4, you decide to jump to step 1, then step 2, then step 3, then step 4. From step number 1, you could have directly jumped from 1 to 3 and then to 4. So there are 2 ways of climbing this staircase. After that, from step number 2, you could have directly jumped from 2 to 4. So this is the third way of climbing the staircase. Now, from the ground you have already taken step 1. Now you could have jumped to step 2. From there you can go to step 3, then step 4. And from step 2 you could have directly gone to top of the staircase. So there are 1, 2, 3, 4, 5 ways of climbing the staircase. If you closely look at these numbers form an interesting pattern, which is Fibonacci series. 1 plus 1 equal to 2, 1 plus 2 equal to 3, 2 plus 3 equal to 5. Let's take an example. When s equal to 3, you have 2 choices. You can jump to step 1 or step 2. If you decide to jump at step 1, then you have only 2 steps left. We have already calculated for step 2. If you decide to jump to step number 2, then you have only 1 step left, which also we have already calculated. That's why we sum these 2 previous numbers and get to the result. The relationship can be represented mathematically by summing up 2 previous numbers, s minus 1, s minus 2, in order to get the value for s. This formula uses a recursive function which requires base conditions. In our examples, we have already calculated our base conditions where s equal to 0 and x equal to 1. So let's define our function, which returns an integer, which will be number of ways to climb staircases, and the name of the function is ways, which accepts an integer s, which is number of steps. So the base condition is if s equal to 0 or s equal to 1, then return 1 like this. Else we can use our formula to return number of ways, s minus 1 plus ways s minus 2. The second is not very efficient. Let's examine for s equal to 4. In order to calculate the value for ways 4, it requires the value from ways 3 and ways 2. To get the value for W3, it gets the value from ways 2 and ways 1. Ways 2 will get its value from ways 1 and ways 0. And ways 2 will get its value from ways 1 and ways 0. You can clearly see that ways 2 is getting calculated twice. Similarly, ways 1 and ways 0 are also getting calculated multiple times. This problem can be solved by remembering the return value of each function call. This procedure is called memoization. In this procedure, we create a map of int and we call it memo. We first try to find the value in this memo. If memo dot find s not equal to memo end, then return memo s. If we find the value in the map, then we can return that value. Otherwise, we just look for the values s equal to 0 and s equal to 1 and then return 1. Else, instead of returning our recursive calculation, we store this value in the map. Memo s and then return memo s. That's it. This technique can be used for any recursive function. Thank you very much for watching my video. If you liked it, please subscribe to my channel.